At the center of large galaxies, there is a major commonality: supermassive black holes. Our own Milky Way circles around Sagittarius A star, an estimated 4.3 million solar masses, which is roughly equivalent to 1,431,900,000,000 times the mass of Earth. However, as supermassive black holes go, Sagittarius A star is still quite small, especially in comparison to black holes such as TON 618 and Messier 87, 66 billion and 6.5 billion solar masses, respectively. We know these giant black holes exist in our universe, but there's one major problem with them. How did they get so big? The universe isn't old enough for black holes to have been able to grow this big through devouring matter and merging together, so there must have been something else happening. Which brought us to black hole stars, or quasi-stars. These gigantic stars are no longer possible in our modern universe full of empty space. Back in the early universe, though, everything was much closer together and hotter. Combined with dark matter halos, this allowed massive gas clouds of pure hydrogen to build and for colossal stars to form within them. Unlike the stars born later in the universe, these gas clouds were too dense and big to be blown away in the initial creation. So quasi-stars were able to be continually fed more and more gas until they reached billions of miles in radius and tens of thousands of solar masses. Quasi-stars could outshine small galaxies, but the same gigantic mass that allowed them this was their ultimate downfall. The weight of gravity pressing in on the stars would crush the center so much that a black hole formed within the star. While gravity force-fed the black hole more and more mass, energy and radiation created by this process pushed back out against gravity and kept the star alive despite the raging parasite within it. After millions of years of this process, there would be so little mass left in the star that the radiation would win, causing the quasi-star to explode and leaving behind a black hole 100,000 solar masses inside. The seed for our modern supermassive black holes.